Let us look at an example of causal relationship forecasting. Avinash Sharma, a production manager, is in the process of preparing forecasts for a product as part of the planning process in his company. He knows that the sales of the product will be impacted by the advertising spend for the product. He has collected the following data for the past 5 months. So the historical data has been collected and given to us in this table here. For month 1, the advertising budget in thousands of dollars was 2.5 and the sales in thousands of units was 264. For the second month, the advertising budget in thousands of dollars was 1.3, while the sales in thousands of units was 116, and so on. Now, in order to forecast the demand for the next month, he needs to know the advertising budget for the next month. So he meets with the marketing manager, who informs him that the company is planning to spend $1,750 next month on advertising for the product. Assuming that you are in Avinesh's position, use linear regression to develop a forecast for this product. Now let us first understand what is meant by causal relationship forecasting. As seen in the other videos of trend projection, a trend line is fitted to the given data and then projections are made into the future using this line. For obtaining the trend line, the given historical data is first plotted on the graph where the time scale is represented on the x-axis while the sales is represented on the y-axis. So a typical trend projection graph will look something like this. On the x-axis generally we have time, whereas on the y-axis we have sales, and then you have the data points, let's say something like this, and then a regression line is drawn based on this data provided to us, and then this line can be further extended in future, and then for a certain time period, let's say this time period, we can then find out the sales from this graph. So this will be the sales. So this is a typical trend projection. Now this is known as the regression line. Time in this case is the independent variable and sales is the dependent variable. So as mentioned earlier, in trend projection basically we have time on the x-axis and time is the independent variable. Now in the causal relationship forecasting, the independent variables can be factors like advertising spend, pricing of the product, competitors' prices, and so on. And these factors have an impact on the dependent variable like sales of the product. So basically what this means is that if the advertising spend is changed, then the sales will be different. If the pricing of the product is changed, then again the sales will be different. And if the competitors change their pricing, then again it will impact the sales of your organization. Now this relationship in the variables is known as the causal relationship. Where the occurrence of one event causes or influences the occurrence of the other event. Let us take another example. If the weather service predicts that the next winter is going to have an abnormally large number of snowstorms, then more people will go out and buy snow shovels and snow blowers in the fall season. So once these factors which influence the dependent variable are determined, linear regression can be used to arrive at the regression line, which can help in arriving at a forecast for the dependent variable. So basically in case of causal relationship forecasting, on the x-axis instead of time we'll have these independent variables like advertising spend, pricing, and so on. While on the y-axis we will have the dependent variable like sales. And the relationship between these two, that is the independent variable and the dependent variable, is assumed to have a linear relationship. So the graph for causal relationship will look something like this. On the x-axis we have advertising spend, while on the y-axis we have sales. And then we can plot the data points and then plot the regression line, and if needed extend into the future. So this is the regression line. So in the example given to us, sales is the dependent variable and advertising expenditure is the independent variable, and the relationship between them is assumed to be a straight line. Now this can be represented as the equation of the straight line, which is y is equal to a plus bx. Now as we have seen, sales is on the y-axis, so this y represents the dependent variable, x represents the independent variable, and in our case this is the advertising spend. A is the y-intercept of this line and b is the slope of the line. So basically if we know the values of a and b in this equation and then we put a value of advertising spend for one of the future months, that is the value of x, then we'll be able to find the corresponding value of sales, which is the value of y. So the key is to find the value of a and b. So from this equation, if we bring a on one side, a is equal to y minus bx. And since we have multiple data points for x and y, what we'll do is we'll take the mean of x and y to find the value of a. And b can be calculated as sigma x multiplied by y minus n x bar y bar divided by sigma x square minus n x bar square. So here A is again the y-intercept, B is the slope of the line, y bar is the average of the y values, x bar is the average of the x values, and n is the number of data points. So for this example, let us first find the values of A and B and then find this regression equation. So this is the data that has been provided to us. We have advertising spend for each of the months, which is X in our case, and sales for each of the months, which is Y in our case. Now first we'll try to find out the value of B, for which we need the individual values of X multiplied by Y. So we have to multiply each value of X with the corresponding value of Y and then find the sum. That is the meaning of this term here, sigma xy. So let us find this first. So for the first one, 2.5 multiplied by 264. So let me pull my calculator here. So 2.5 multiplied by 264. So this is 660. Next is 1.3 multiplied by 116. 1.3 multiplied by 116. 150.8. Next is 1.4 multiplied by 165. 231. Next is 1 multiplied by 101, which is 101. And next is 2 multiplied by 209, which is 418. Now we have to take the sum of all of these values. So 660 plus 150.8 plus 231 plus 101 plus 418, 1560.8. So here we have the value of sigma xy. Next we have to find out n, which we know is 5, x bar multiplied by y bar. Now x bar is the mean of x values, so x bar is equal to the sum of all the x values divided by the number of values, which is n. So here we have to find the addition of all of these, and y bar is the sum of all the y values divided by n. So here we have to find the sum of all the y values. So let me pull my calculator. 2.5 plus 1.3 plus 1.4 plus 1 plus 2. So sigma x is 8.2. So this is 8.2 divided by n, which is 5, and this is equal to 1.64. Now let's do the same for y values. Let me note the total here. So this is 8.2. So 264 plus 116 plus 165 plus 101 plus 209, 855. So this is 855 divided by 5, and this is equal to 171. Now this total is 855. So we can now find the value of n multiplied by x bar multiplied by y bar, as we have all the values available. Next we have to find the addition of all the x squares. So this is x, so we have to find the corresponding value of x square and then sum it up. So let's find the values of x square. So 2.5 square, so we know that 25 square is 625, so 2.5 square becomes 6.25. 1.3 square, so we know 13 square is 169, so this becomes 1.69. 14 square is 196, so this becomes 1.96. 1 square is 1 and 2 square is 4. Now let's add these up. So the total comes out to be 14.9. So we have the value of sigma x square, and we also have the value of x bar, and we can easily find the value of x bar square. So actually to find b and a, we don't need y square. So let me remove this. So let us now plug in the values in the formula for b. So b is equal to sigma xy, which is this 1560.8 minus n, which is 5, multiplied by x bar multiplied by y bar. X bar is 1.64 multiplied by y bar, which is 171, divided by sigma x square, which is 14.9, minus n, which is 5, multiplied by x bar square, which is 1.64 multiplied by 1.64. So let me pull my calculator here. Let us first find the value of 5 multiplied by 1.64 multiplied by 171. So 5 multiplied by 1.64 multiplied by 171. Enter. Now this is negative and then plus 1560.8, which is 158.6. So this is 158.6 in the numerator, and let's now find the value of the denominator. So 14.9 minus 5 multiplied by 1.64 multiplied by 1.64, this is 1.452. 1.452. Now let's find the value of this. So since this is in denominator, I'll do a 1 by x of this and then multiply with 158.6. So this is 109.229. 109.229. So this is the value of b. Now let's substitute this value of b in this equation to find the value of a. So a is equal to y bar, which is 171, minus b, which is 109.229, multiplied by x bar, which is 1.64. So 171 minus 109.229 multiplied by 1.64, this is minus 8.13556. So let us round it to minus 8.136. Now as we had seen earlier, the equation of the regression line is y is equal to a plus bx. So here let's plug in these values. So y is equal to minus 8.136 plus b, which is 109.229x. So this is the equation for the regression line. So now if we want to find the value of y, which is sales, for a particular value of X, which is the advertising spend, then we just need to put the value of the advertising spend in this equation and we'll get the corresponding sales. Now we have to find the forecast or the forecasted sales for the next month, for which the advertising spend is expected to be $1750. Now since we have taken all the X in terms of $1,000, we'll consider this as $1.75,000. So this is the value of X. So let's plug this into this equation. So Y is equal to minus 8.136 plus 109.229 multiplied by 1.75. So this is equal to 183.015, and this is the value of the sales or the forecasted sales for the next month. And now we have also considered the sales in terms of thousands of units. So this is also in thousands of units. So the actual sales is 183015 units. So this is the forecasted sales for the next month. Now let's perform some test for the accuracy of this forecast. So there are three measures of forecast accuracy. The first one is known as the correlation coefficient. The second one is known as the coefficient of determination. And the third one is known as the standard error of the estimate. Now all the three can be used to judge whether the independent variable chosen for the model is a good choice. So in our case, basically the production manager Avinash Sharma came up with an analysis that the advertising spend is going to impact the sales. Now how good is the relationship between advertising spend and the forecasted sales is what we will find out using these three measures of accuracy. So let us first find out the correlation coefficient. Now correlation coefficient is represented as small r, and the formula is sigma, where I is equal to 1 to n, xi minus x bar multiplied by yi minus y bar divided by square root sigma I equals to 1 to n xi minus x bar square multiplied by sigma I equals to 1 to n yi minus y bar square. Now what this means is that first we have to find out the values of xi minus x bar, then we have to find the values of yi minus y bar. We have to multiply the two and find the sum of all these values. For the denominator, we have to first find the values of xi minus x bar, square them up, find the sum of them, then we have to find the values of yi minus y bar, square them up, sum them up, and then multiply the two sums that we have found. So let us find the value of correlation coefficient for this example. So let us first find the value of xi minus x bar and then yi minus y bar. Now we had already found out that x bar is equal to 1.64 and y bar is equal to 171. So xi minus x bar and then yi minus y bar. So for the first one, 2.5 is the value of xi minus x bar, which is 1.64. So this is 0.86. Next is 1.3 minus 1.64. This is minus 0.34. Then next is minus 0.24. Then minus 0.64 and 0.36. Now yi minus y bar, so y1 is 264, y bar is 171, so 264 minus 171, this is 93, then 116 minus 171, which is minus 55, then minus 6, minus 70, and 38. So we have found the value of xi minus x bar and yi minus y bar. Now we have to multiply the two and find the sum. Now next we have to find the value of xi minus x bar multiplied by yi minus y bar. So that is, we have to multiply these two. So 93 multiplied by 0.86 is 79.98. Minus 0.34 multiplied by minus 55, this is 18.7. Minus 0.24 multiplied by minus 6, this is 1.44. Minus 0.64 multiplied by minus 70, this is 44.8. 0.36 multiplied by 38, this is 13.68. Now let's find the sum. So the sum comes out to be 158.6. So here what we have done is we have found out the value of the numerator, which is 158.6. Now we have to find the value of xi minus x bar square. So we already have xi minus x bar. We have to square it up and then sum it up. Then we have to find the value of yi minus y bar square. We already have yi minus y bar. We have to square this up and then sum this up. So 0.86 square is 0.7396. Minus 0.34 square is 0.1156. Minus 0.24 square is 0.0576. Minus 0.64 square is 0.4096. 0.36 square is 0.1296. Now we have to sum this up. So the sum is 1.452. Now we have to find the values of yi minus y bar square. So 93 square is 8649. 55 square is 3025. 6 square is 36. 70 square is 4900. And 38 square is 1444. So let's sum this up. The total comes out to be 18054. So let us now plug these values into this formula. So R is equal to xi minus x bar multiplied by yi minus y bar, which is this column, and we have to find the sum of it, which is 158.6. 158.6 divided by square root xi minus x bar square, which is this, and the sum of it, so 1.452 multiplied by the sum of yi minus y bar square and the sum of it, which is 18054. So this is equal to 158.6 divided by 161.9, and this comes out to be 0.98. Now this value came out to be 0.98. Now what does this mean? So basically R can range from -1 to 1. So if I take a scale here, this is 0, this is minus 0.5, and this is -1, this is 0.5, and this is 1. So at these 2 points the correlation is strong. At these 2 points it is weak, and at 0 no correlation. In other words, the correlation is strongest at the edges, which is -1 and 1, and as we come towards 0 the correlation becomes weaker. So 0.98 is towards 1, which indicates a pretty strong correlation between the two variables. Now next we'll find the coefficient of determination. Now coefficient of determination is nothing but r square, and the formula is sigma I equals to 1 to n yi minus y bar square minus sigma I equals to 1 to n yi minus yi dash square whole divided by sigma I equals to 1 to n yi minus y bar square. So basically this first term and the denominator are the same. Now this r square is nothing but the square of this r. So the value of r is 0.98. So the square of this comes out to be 0.96. However, let's use this formula to find out the value of r square, and then we'll compare it with this. So this is the formula that we have to find out. The first term is yi minus y bar square and the sum of it. Now as part of the calculation for correlation coefficient, we have already found the value of this term, which is 18054. So now what we need to find out is yi minus yi dash square and the sum of it. Now we have the values of yi, we don't have the value of yi dash. Now what is yi dash? So if this is the graph between the independent variable and the dependent variable, and let's say these are the 3 points and this is the regression line. So this point is considered as yi, which is this point, which is the actual data point that is given to us. And corresponding to that, there is a point on the regression line which is yi dash. So this is what this term is. Now how can we find this out? So we can find this out using the regression line equation, which we had found in the previous steps, and it is y is equal to minus 8.136 plus 109.229x. So this is nothing but yi dash. So basically what we'll do is we'll put the value of x in this equation and we'll get the corresponding value of yi dash on this line. So we'll put this value and we'll get this value. So y1 dash is equal to minus 8.136 plus 109.229 multiplied by x, which is 2.5. So this comes out to be 264.9365. y2 dash is equal to minus 8.136 plus 109.229 multiplied by x2, which is 1.3. So this comes out to be 133.8617. y3 dash is minus 8.136 plus 109.229 multiplied by x3, which is 1.4. So this comes out to be 144.7846. Similarly, we can calculate the values of y4 dash, which comes out to be 101.093, and y5 dash, which comes out to be 210.322. So first we have to find out the value of yi dash, and this is yi. So what we found is 264.9365, 133.8617, 144.7846, 101.093, 210.322. Now next we have to find out yi minus yi dash. So this is minus 0.9365 minus 17.8617. So basically what I'm doing is this term 116 minus 133.8617, and this is the value. Similarly 165 minus 144.7846. So this is 20.2154. 101 minus 101.093, so this becomes minus 0.093. 209 minus 210.322, so this is minus 1.322. But we have to take the square of this, so we have to find the square value. So yi minus yi dash square. So basically minus 0.9365 square is 0.877, minus 17.8617 square is 319.04, 20.2154 square is 408.662, minus 0.093 square is 0.008649, minus 1.322 square is 1.747684. And then we have to take the sum of this. So we have to take the sum, which comes out to be 730.335. Now let's substitute these values in this formula. So r square is equal to yi minus y bar square and the sum of it, which is 18054. So 18054 minus yi minus yi dash square, which is 730 0.335 divided by again 18054. So this is equal to 17323.665 divided by 18054, which is equal to 0.96. This is the value of r square. So as we had seen, the value of r square came out to be 0.96, and which is nothing but the square of this value, which is 0.98. So if you are not being asked to calculate the correlation coefficient, then you'll have to use this formula to find out the value of coefficient of determination. And if you have already found out the value of correlation coefficient, you can either square the value of r, or you can again find the coefficient of determination as per the requirement. Now the values of r square range from 0 to 1, and the values which are closer to 1 are more desirable. So this value is closer to 1, so this is a good number for the data provided to us in this example. Now third is the standard error of the estimate. So standard error of the estimate is represented as sigma xy, and the formula is sigma, where I equals to 1 to n, yi minus yi dash square divided by n minus 2. Now this value we have already found out in the previous step, and the value came out to be 730.335. So let us substitute this value. 730.335 divided by n minus 2. N is 5. 5 minus 2 is 3. So this is equal to square root of 243.445. And this is equal to 15.6. So based on these three measures of accuracy, which is correlation coefficient came out to 0.98, the coefficient of determination came out to be 0.96, and standard error of the estimate came out to be 15.6, it appears that advertising spend is a good choice for predicting sales.